watching the Target 5.2 retest video. In this one, we're going to learn how to simplify the square roots, possibly get imaginary numbers, that kind of stuff. So make sure you take out your packet. You need to have this finished before you are allowed to retest. Here we go. We're going to pick out number 5, 6, 7, and 8 here to start with. Number 5 and number 6 are just straight square roots. 7 and 8 are a little different, and 13 and 18 look like the quadratic formula. So we'll go through these 6, and then any additional help you need, see your teacher before or after school or during advisement works too. Here we go. So the way I like to see these done is splitting this up into 3 parts. And one part is going to be a perfect square, another part is going to be a non-perfect square, and we're going to save that middle part for the imaginary numbers. So perfect square list, 1, 4, we don't put 1 on there because it's not really simplifying anything, but 4, 9, 16, 25, 36, 49, they keep going, and these are just 2 squared, 3 squared, 4 squared. That's how you generate this list. So if you can't remember exactly how to generate or memorize this list, you can generate the list by squaring each of these integers, and you end up with a list of perfect squares. It doesn't stop at 100, but that's where I will stop for the purpose of this video. You could actually keep going. Now, the square root of 28, we look for the biggest perfect square that goes into 28. And if you notice, see, 25 doesn't, 16 doesn't, 9 doesn't, but 4 does. 4 does 7 times. So we put the perfect square in the first one, the non-perfect square in the second one, and the check is that 4 times 7 gives you 28. And there's no imaginary piece, so we won't use that middle one. So simplifying the square root, square root of 4 is just 2, and square root of 7, the second square root will never be able to be simplified. So there's your simplified term. Okay. Again, perfect square, imaginary part, non-perfect square. So 54, 64 does not, 49 does not, 36 does not, 25 does not, 16 does not, oh, 9 does. 9 does 6 times. So we'll put 9 and 6. 9 times 6 is 54. And then there's that negative 1. And that's the imaginary piece. So the square root of 9 is 3. The square root of negative 1 is I. And then the last part will never be able to be simplified because it's not a perfect square. All right. And we have number 8. And I believe there's a minus sign under both of these. And this looks like if you were to solve using square roots, you'll get answers that look similar to this. So the first step is being able to simplify the square root, square root of 12. That is 4 times 3, and there's no imaginary part. So it's 2 root 3. So our first piece to our answer is 2 plus or minus 2 root 3. Now in this case, we cannot combine the 2 and the 2 root 3. This is not 4 root 3. Okay. 2 root 3 is not actually 2. It's 2 times the square root of 3, and you'll get a decimal for that. So you can't combine those two. We leave them exactly how it's at. Now the only time that you would use a decimal is if you have contextual problem, so a word problem. If you have a word problem, you definitely want to use a decimal answer for this. And I can go through how you get that decimal answer here in a second. So you would actually have you would actually have 2 plus 2 root 3 and 2 minus 2 root 3. So we need the square root of 3 to start with. And then we multiply by 2. And then we're going to add 2. So this answer is 5.46 as a decimal. And the other one, the square root of 3 times negative 2. And we'll add 2 to that. And for this one, we would get negative 1.46. So if this was an actual word problem, we would want those answers. But it's not a word problem, so we leave this as our simplified answer. Okay, so to recap really quick, the only time you use decimals is in a word problem. All right, number 7 then. Square root of 9. Ooh, 9 is a perfect square. So 1 plus or minus 3. Now I had a lot of people actually write this like this. Oops. The square root is already gone once you do the square root of 9. So we're not going to write that as the square root of 3. It's just 1 plus or minus 3. Not quite done though. This is 1 plus 3 and 1 minus 3. And since these are both integers, we can put them together. They're like terms. 4 and negative 2 are the answer. Okay, sliding over to 13 and 18, these look like quadratic formula results. So again, 25 is a perfect square. I want you to see that when you get a perfect square, you actually have two numbers, two integers that you can combine. 1 plus 5 over 2 and 1 minus 5 over 2. Okay, whereas if you have a square root in the answer or an imaginary number, like number 18, square root of negative 9 is 3i. You'd have negative 3 plus or minus 3i all over 6. You can't combine the 3 and the 3i. They're not like terms. But you should also check and see if all three numbers can be divided by a greatest common factor. And in that case, it is 3. So I'm going to write my final answer, dividing everything by 3. There you have it. Again, one more time, if you see a word problem, give us an answer in decimals. If you don't see a word problem, don't give your answers in decimals. There you go, finish that sheet of simplifying, and then you'll be allowed to retest.